Limits are an extremely important concept in calculus. You've learned what the derivative is, and a preview into how we find it. We could think about how to find the derivative of f of x at the point x star by finding the slope of a secant line that passes through x star and another point on f of x. So if this is the secant line, let's say it goes through the point x star and x star plus h, where this distance we'll just call h. The slope of this secant line is the rise over the run, so this distance here divided by this distance here. What is the rise? Well, it's f of x star plus h minus f of x star. So here, if we visualize the y-axis, you can see this a bit better. And the run, then, is what we're calling h. We can get a better approximation of the slope tangent to the point x star if we choose a different point that's closer. So if we pick this point, then the secant line better approximates that tangent line. It's still not perfect, so we'll pick a point even closer. And we want to get infinitely close to the point at x star. So what does that mean? F prime of x star, in other words, the derivative at x star, is equal to the limit as h approaches 0, because this point is getting closer and closer and closer to x star, so h is getting smaller and smaller and smaller. And it's the limit of this. Isn't that so cool? We can use this complicated concept, which won't be complicated after you get the hang of it, and we can find the slope of a function at any point. Let's do a really simple example. Let's say f of x is x squared, and we want to find f prime at 2. In other words, what's the derivative at x equals 2? And again, in other words, what is the slope of the tangent line at x equals 2? So we can kind of have some idea of what this would be because we know what x squared looks like. So at the point x equals 2, it'll have a positive slope. But what is the slope? To find it, we'll take the limit as h approaches 0 of f of 2 plus h minus f of 2 divided by h. But f of x is x squared, so instead of these, we're going to have 2 plus h squared, and f of 2 is 2 squared. So let's simplify this. If we multiply out the numerator, we get this. And then after we simplify, we have 4 here minus 4 here. So those cancel out. And then we have an h in the numerator and denominator. So we can cancel out an h. So this becomes 4 plus h. So now what's the limit as h approaches 0? This whole thing approaches 4 plus 0, which is 4. So the slope of the line tangent to x squared at x equals 2 is 4. In the exercises, practice finding the derivative at various points for these different functions using the limit.